So today I discuss the simple application of refraction of light, part C, refraction of light. Okay, so for C, simple application of refraction of light. Simple application of refraction light. Okay, the first application we discuss what is real depth and what is apparent depth. Discussion here is what is real depth and apparent depth. Okay, so short form real depth is RD and apparent depth is AD. Okay, so for understanding of real depth and apparent depth, so take an example. First example, a practical example here: a bucket of water. Okay, a bucket of water. Take take a beaker full of water. That is the upper part of the beaker full of water. So a object or consider there is some coin at bottom of the beaker. Coin place bottom or object and down in the beaker. Okay. So a observer here. Observer. So light travel. If we consider the object as source of light, so if the light travel from denser to rarer medium, okay. So there is a receiver. This object as a coin is a source. So light travel. Uh, State path. Okay, actually, it's a very complicated drawing. No? Okay. Okay, there's an incident ray, and this line is considered a line of incidence, and that is a point of incidence. And here we draw a normal. Okay, and if light travels from denser to rarer medium, we know that the refracted ray bends away from normal. So the refracted ray bends away from normal, slightly bending here. Okay, actually slightly bending away from normal. Okay, so that depth is a real depth. Okay, so that depth of the original depth of the coin is a real depth, RD. Okay, and what is the apparent depth? When observers see the object, we know that light traveling straight path. If it is a air, and suppose it is a water, and you know the water is more denser than air, so there is a mismatch of refractive index here. That's important. If both density of air and water same, if I say that, let's say assumption, okay, if both density air and water same, then light travel straight path. So observer actually see a state path like this. Observer actually see that state path. So that is considered dotted path. Consider the dotted path. Okay. The observer see. Now we consider the top view of the object. The top view. Okay. So the top view of the object is like here. Like the top view. Someone see the object at top point. So you know that that is consider light travel from top view consider top view there's a bending, but light travel state path. Okay, it's a complicated drawing a straight line. So top view. So if that is up from there, it is back. Okay, if that is a incident ray from here, incident ray, that is a line of incident here. Okay, that is a normal. If a incident is normal on the surface and refracted is also normal, so there is a no bending here actually. So okay, they are parallel to a normal. Okay, so that means there is a no bending. So check that there is a if both air and water are the same density. So light travel state path. So there is a original main, let us say, assumption. Okay, let's say, and that is someone, the person P. There's an original person here. See that the state path. So actually, there's a meeting point. That is a meeting point. If someone's at a vertically at the or top view of that object and the slanting view, both are the meet at that point. The observer, main observer or viewer, see that the object not placed here, actually object in here. So that depth from top of the surface to here is called top of the surface to at that point is called apparent depth. That is not actually real depth. Is a apparent depth. That depth is called AD, apparent depth. Okay, that's a apparent depth. Clear? So some consideration here important. Some consideration means so object always placed in dense medium. Okay, then object is an object that placed in a denser medium. Placed in a denser medium. Okay, and when viewer from a rarer medium, viewer or observer, and when or observer are rarer medium and appear to be the bend of, so if see that medium actually and actually the depth of the object appears when an object appears a depth lesser than the real depth, appears depth lesser than the real depth, real depth, and this because the refraction of light. This of refraction of light. Okay, the first application. The object are in what dense medium. See, the object is height. Some that is shifting. Okay, thus, and this is called this distance called shift. So shift equal to real depth minus apparent depth. Okay, clear. So now if I calculate the shifting, calculate shifting, and what is shift, how the object shift and what factor is depending the shift. Okay, now calculate the shift. Next here calculate shift. Now copy the diagram first. Okay, copy the diagram. Let's see. One, three. Okay, so if first to check, see that if that is the incident ray, that is the incident ray, and there's a normal, so that angle, some geometry important, that is the I incident angle, and light travels from denser to rarer medium. So that is a R refracted angle. If a normal and is vertically seeing the object, this line is also parallel to normal. This line and this line are parallel. So this angle I and this angle I, that is the alternate angle. Okay. Similarly, that is the R, this angle, a normal and this line also parallel, and this line a straight line. Okay. So that is a R and that is a R. Let's call R. This is I think corresponding or adjacent angle. Okay. Now these two angles are same. Okay. That is this angle are the same angle. Now we calculate shifting. This is very important. And the shifting is called, small name is S. Okay. So this shift is S. Okay. So now this is basic algebra actually. Okay. There is a name A, that is point B, C, and this point is D. So from Snell's law, you know that Snell's law said refractive index of medium. Okay, actually, so mu, light travels from any medium, water medium to air, M to A, that is equal to sine I by sine R, that is Snell's law. Now I calculate what is sine I and sine R. Okay. So first we consider a triangle ABD triangle, that is this angle is 90 degree, the angle A is 90 degree. So sine R, that is equal to, from trigonometric ratio, perpendicular by hypotenuse. So AD by BD, and similarly the triangle, see that ADC or ACD triangle, sine I, that is also AD 90 degree, A angle 90 degree, so AD perpendicular, angle 90 degree. So AD by CD hypotenuse. Now these two value put here. Mu medium to air, A to M, sine I by sine R. So sine I is AD by CD, AD by CD, and R is that AD by BD. So reciprocal of BD by AD. So we cancel. So BD by CD. So now if a reciprocal of this means A to M, light travels, that is 1 I mu medium to A, light travels, that is equal to 1 by BD by CD, that is reciprocal of CD by BD. Okay. That's important here. Now, from calculating the depth, shifting, we are taking some assumption here. So, some these assumptions called some boundary condition, taking some assumption. Assumption. If that if A and D is very close, A and D point A and D, point A and D is very close, means actually, so uh, AD is much sorry, AD is found very close, is almost negligible. Okay. Uh, okay. So actually, that very close means say that the AD is almost negligible. AD is negligible. AD is negligible. So viewer, receiver are very close from here. Actually, viewer is very close from here. Actually, okay, close, very close from vertically above the object. Okay, very close. Viewer is very close, close at a point of vertically above the object. Viewer is very close. It is negligible. Okay, viewer is very close to vertically point at that point here. Okay, that's why it is negligible. So if AD is negligible, so we say that if AD negligible, so AB say that is also equal to BD. If this line is almost zero, to say that BD overlap to AB, that's equal. And similarly, if AD is very uh, close and A at D point is very close, means AD is almost negligible. So we say that AC is also equal to CD. AC is also equal to CD. Now put that these two from here, we get mu A to M. That is CD means AC and BD means AB. So what is the AC? AC means a real depth. Real depth. And what is the AB? AB say that is the apparent depth. Apparent depth. Then the final we will get from the apparent depth AD, that is equal to real depth RD by mu light travels air to medium. That's mean the refractive index of medium. Okay. So shifting. From shift you know that it is shift is RD minus AD, real depth minus apparent depth. The shift actually shifting, that is equal to real depth minus apparent depth. So here real depth minus apparent. So that is the real depth. Now replace apparent depth by these RD by real depth by mu A to M. Now RD take a common, 1 minus 1 by A to M, that is shift S. Okay. The shift by the object appear to be raised. So actually the object is raised. How to define the object is raised? See, when the observer see the object in a bucket of water, the viewer observer see that the object is some little bit lift. But same object when observer was in a normal eye in a outside the bucket of water. Uh, so see the object is really some original depth. So observer now clearly distinguish between these two depths. Same object place inside a water bucket of water and same object beside the air with the outside the bucket of water. See that there is a difference, actually depth difference. Okay, that is a depth difference here. So observer see that is the original depth outside the bucket, that is a some apparent depth inside a bucket, and there is some shifting. That shifting is the cause of application called the refraction of light. There's an application. Okay, all right. That shifting is depending on some factors. First factor is depending on factors. Shift depending on some factor. First factor is the Ri of the medium. Ri of the medium means water, glass. Okay, in a medium. Next, thickness of the denser medium. Thickness of the denser medium. And next, third point is color of light. Color of light. That's the point is very important. So the thickness means actually that is the color. See that actually the real depth is very important here. Also call that if that glass is more thickness, so I think same of water, so real depth is small. So that thickness is very important. Okay. Now next page we discuss three factor part by part. So depending the shifting on refractive index, first part we discuss how related to the Ri of the medium. Higher refractive index of medium is more shift. If Ri is proportional to shift. If Ri increases, shift also is more. And if Ri is less, shifting also less. So higher effective index gets more shift. Lower effective index gets less shift. They are directly proportional. Next, number two, thickness of the denser medium. More thicker, more shift. So thickness also directly proportional to shift. More thickness means more shift. Less thickness means less shift. Number three factor, color of light. Because color of light is very important, because color of light defines the Ri. Yes, color of light is also defines the Ri. So you will know that the mu of violet is more than mu of R. So similarly, the shifting of violet is greater than shifting of R. Is more Ri means more shift. So similarly, that shifting of violet is also more than compared than R. So clear. So actually that is the important. And another factor is shifting is decreasing, increasing wavelength. Okay. So lambda versus if I draw that shift, they are inversely proportional. Lambda is inversely proportional to shift. If more wavelength means less shift. Means if more less wavelength means more shift, because you know that lambda and mu they are not directly proportional. Actually there is a difference. Clear? But take another example here. If mu A to G, air to glass is 3 by 2, 1.5 effective index of glass, and similarly the mu of air to water, that is 4 by 3, that means suppose 33 continuation. So see that is a refractive. So here mu of G is greater than mu of water. So shifting of glass is greater than shifting of water. G stands for glass. Uh, W stands for water. Clear. There's some example here taken the apparent bending of a stick underwater. Hmm. Uh, Bending of a stick underwater. Okay, because some consider this a bucket of the, okay, that is water here. That is water here. So if that is a pleasant stick, actually this is a stick. Mm, this that is a stick, original stick. Now, a viewer or observer eye is here. Mm, the eye is here. It's here. Okay. See that. Uh, so, suppose okay. Now the bending of that light, uh, then denser to rarer, that bending. So if I joining these lines, okay, straight path, okay. So the end of the stick rise here. So end of the stick now rise at that point. Now let's see the observer here, the bending of light. The observer sees, then the actually here is a bending. Yeah. So that is that is AD apparent depth, that is RD real depth, that is S shift. Okay, so that's the bending. This is the bending. Okay, bending. Due to that, bending is mainly important as the density mismatch here. Okay, that's why the bending is placed. Okay. That's why see that's a bending. But actually, it's not bending. But reality is stick is present here already. But that's the mismatch of density. That is another application of refractive index of light. Yeah, that's why it is a bending is placed. If that same part, the someone say uh, opposite of that these, okay, the observer are in air medium. Now if I observer in the underwater and the object are placed in air, what is happening? So okay, there is a denser, that is the rarer medium, there is the observer, okay, there is an object, and see that object light travel from air to denser medium. So that is a normal. Due to this, so actually these are the painting. Okay, observer eye is here. Okay, but observer knows light traveling state path. So okay, so actually. mm, mm, okay, there's a bending here to medium, but they are in state path. So state path. So that is a similar in particularly upward. Uh, So the object now under the water, observer see the object, there is a shifting upward. Okay. Same as that object are in air medium. Okay. Okay, here object are some rise and object are far away. Okay, actually the object here, but see the object is here. The object is slightly far away from the original position. Okay. Some consequence of refraction of light. Some consequences very important. Very some of eye of refraction of light. Refraction of light. Star appear twinkling. Okay, star twinkling. Mhm. Because the change of refractive index, because sky layer of the sky's density are not same, so there is a mismatch of the density, so that is refraction. That's why the bending is present. Okay, the air and temperature refractive index are different. And second is sunrise. Sunrise uh, seen few minutes before the rise. Uh, seen few minutes before, because that is sun, that some medium, huge type of medium, that is the earth, that is earth, and some observer line up here, observer standing here. So light travel actually these paths, mm, uh, bending, and the observer see the object in, see actually sun, see here. So observer see the sun is, that is the original. Now observer see that the sun are in here. That due to that say the for refractive index. Sorry, due to the mismatch of the density or a refraction. Mainly actually there is a refraction because the more denser air is the more denser in near the earth surface. Okay. So coin in the vessels is not visible in the see just below the edges. The vessels can you view the some position of the water pour in the vessel. Okay, if someone if that is a vessel here, third point. There is a coin here and the observer here, so they do not perfectly see the object here. If you pour the water, then the object is slightly lifted up, so then observer see the object is here. Okay, now distinguish the object. Okay, that's a coin, a coin kept in vessels, are not visible. Uh, One put water uh, water um, visible coin. Okay. Similarly, another if a printing paper on a glass appear, if some glass placed on a paper, see that the letter in the paper is some appear. Okay, is some there is some close to eyes. Pen and paper appear to be raises when the glass slab placed cover on it. Similar concept. Water tank appears shallow than the actual depth. The person lays appear to be short when the standing in the pool or water tank. There are some consequences here. Okay. So today in the class here. Thank you.